So welcome everyone to the WasmEdge community meeting. Tonight we've got or today I should say, we've got a really good lineup. We have, first of all, Hydai is going to talk about the WasmEdge 0.10.0 review. And then after that, Sam's going to talk us through the Rust SDK 0.1.0 and the Rust Sys 0.7.0. And then after that, we've got a special guest, the Gran Programming Language co-author, Oscar Spencer, and we're going to talk about a few things about Grain Lang, and hopefully there'll be enough time for you guys to ask him some questions and ask Sam and Hydai some questions. And we'd love to also hear about what projects you're working on and how you're using WasmEdge, and it's going to be a great meeting. So let's kick it off. Over to you, Hydai.
Can you guys share my screen?
Yep, we can see that.
Okay, and today I would do quick review of our latest release. So it will contain 4 parts. So the first part is the breaking changes. In this version, we introduced a new mechanism called the plugin system, which is just provide a standalone interface for those developers who want to, write a host function and want to distribute their host function as a plugin to our WasmEdge ecosystem. So here is our, first break change is the plugin system, and also we make our one of our host function called WasmEdge process and become the first plugin. And we encounter lots of issue on the Mac OS and the Windows platform. So I will mention that in the next slide. However, we will we plan to have maybe a hackathon or some change for those who want to contribute their idea as our plugins. So we may have have a new hackathon for it. And the second branch change is that we implement a shortcut in the universal Wasm format, which is if we found the there is the native binary is contained in the universal Wasm format, then we will skip all of the section, just load the native binary and just execute it. So it will, skip lots of loading time to pass the, those unnecessary Wasm section. So this is 2 major breaking changes in this version. And also we have, 4 important features. So the first one is that we support the tailcode proposal. So now you can use, enable tailcode proposal to leverage this feature. And also we provide some function, which is the, get address information and some UDP functions called receive from and send to in our Wasa socket component. And we will introduce the stressF in lots of our WasmEdge components and also our C APIs. So actually we have a demo to leverage the stress with the WasmEdge to to leverage the multi-threading mandible computation. Yeah, so that's our very interesting feature in this version. And also we finally have source RPM for the Fedora system. Then after this version released, actually we received some issues. So the first one is that we found our prebuilt binary or our prebuilt library are not working on the latest Mac OS. So the first issue is that somebody find our maybe some component related to the WASI socket is not working on the Mac OS, and we are trying to reproduce the environment and to see what's happening. And the other thing is that somebody want to leverage our WasmEdge process module, and he found that when you try to load this plugin, you will encounter the simple not found issue, and this is under the issue 1514. So if you have some some related issue, you can go to this one and provide more information for us, so we can resolve this issue as soon as possible. And also, one of our mentee found that when you try to build fund source with the latest Mac OS release and its M1 model machine, and also it will fail if you use the 12.x version of SDK. However, if you downgrade your Mac OS STD version to 11.x, then it's worked. So we are still need to investigate in this issue. Yeah. So these two are related to our Mac OS, even in the pre-built binary, also build fund source. Yeah. So we are trying to fix them. Then we will introduce 3 proposals in our next release. So the first one is that we want to introduce the threads proposal, and this is under the pull request 1499. And with this, we can make our we can split the workload to several threads and make our WasmEdge to execute partial of the computation per thread, then combine all of the computation result to to accelerate the programming execution. So this is our our first proposal. This is thread, and you can find the improvement result in also under this pull request. And we would merge the WASI, and this NN is mean that the neural network. So you can use this interface to load a AI model and do something like the face recognition, or do something like image inference or something like that. And this is depends on the OpenVINO framework. So if you are familiar with this, then after this pull request is merged, you can use lots of the models which is supported by the OpenVINO to use this feature. And also we have the very I will say very interesting proposal called the Wasa Crypto. This will enable lots of the crypto functions in WasmEdge. So you can use like do something like sign, or to extract some key, something like that. So if you are interested with this, you can go to this pull request 1282 to see the details. And also this proposal is will need the OpenSSL. So in our master branch, we would not enable these 2 proposals by default, because it requires our user to install the OpenVINO, also install the OpenSSL, which are very large, and maybe to some of our user these are not necessary. So we will disable these 2 under our pre-built binary. However, we will provide more version of the binary which is contain this poll. So due to this issue, we may make this proposal become plugged into, to separate these dependencies. So we believe we will bring more, more proposal-related features in our next release. Also, we will, fix this issue as soon as possible. So that's my, quick review of our this release. Thank you.
Thanks, Hydai. That's really great. There's a few things in there. I've got a couple of questions for you if we have some time at the end. Thanks, that was really interesting. We're going to head over to Sam next, and I'll just give him a little minute to get ready. I'll just go down through here and see if there's some microphones on. Is Raofu, your mic is not muted. You feel free to mute your microphone if you want. That's good. All right. So Sam, how are you going? You ready to share your screen or to talk?
Yeah, I'm ready. Wait a moment. I just want to share the slides.
Okay.
Try.
I'll let you know when we can see it. No rush. You good? Okay, looks good. Good to go.
Let me try here. Okay. Hey, let's begin. Okay. Good morning and evening. I'm Sam from Second State. In this meeting, I'd like to share some new achievements in WasmEdge Rust bindings in the recent 2 months. Okay, in this meeting, we like to share something new around the following 4 topics. We'll first talk about the structure of the Rust bindings and the version iteration of each part. And then we'll introduce Wasm SDK Crate. We released last month, mainly focusing on the parts related to the API design. After that, we'll talk about the major changes in the latest version of WasmEdge C's Crate. Finally, we'll talk about some work items that would come in the near future. So now let's move to the first topic. In this slide, this picture shows the structure of Rust bindings. The entire Rust bindings consists of 3 parts. The core part in purple is WasmEdge library. Where it's a C API, we can access the features it provides. The second part is the orange layer, is the WasmEdge C-Crate. We call it the C-Crate. As we introduced in the previous meeting, the design of the C-Crate is to provide low-level but safe APIs by wrapping the C API of the core part. And so its API keeps a similar granularity to the C API. The outermost layer is the WasmEdge SDK Crate. We call it SDK Crate. This is a new Rust crate, and it provides a group of high-level APIs for developers to build up their business logic. Excuse me. We will talk more about the API design of this crate later. This slide shows the release timeline of each part of WasmEdge Rust bindings. From February to last month, Crate has already released 5 versions, each version per 20 days in average. Each release implements one or more key features and makes it a lot of improvements based on the previous version, such as reliability, code and document quality, and etc. Maybe some of you noticed we didn't list the version 0.6 here. The reason is that we finished 0.6, but we didn't publish it on Chris.io, as the core part at that time was experiencing a significant refactoring and brings about a number of new APIs. So we decided to move on, and based on the new version of the core part and also the 0.6 to build up version 0.7. By the end of last month, we released CIS 0.7. It contains a significant amount of changes. We'll talk about it later. In this slide, another important part we want to tell you is we released the first version of SDK Crate. It is the most important part of our Rust bindings. As shown in the previous slide, SDK works as the user interaction layer. Rust developers interact with WasmEdge, where the APIs of this crate. Therefore, SDK is business-oriented, Rustation-oriented, safe, and ergonomics. So now let's see the principles we follow when we design the APIs of the SDK crate. When we design the high-level APIs, we follow these 3 principles: clear, elegant, and rusty. We hope developers can easily get the meaning of each API, even without reading the details in the Rust doc. And when we implement a complicated business logic with the APIs, the final code should be well organized and have a good readability. So next, we'll compare some code samples from SDK and also CIS crates, respectively, to present the difference between high-level and the low-level API design. In this slide, we list 2 code samples, and these 2 code samples present the APIs of config context. The left one comes from SDK. The right one is from CIS. The design principle of the low-level API is just to provide a safe wrapper for the C API and to keep the similar granularity as the C API, and just introduce very limited abstractions. Instead, the high-level API design introduces more abstractions to organize objects and APIs. In this example, the high-level design categorizes different config options based on their semantics, and introduces different option objects to group them. Such a design would help developer distinguish and remember different options easier. The second design principle is to use less code to implement the same idea, so that the final code is concise and clear. In this comparison, the code samples create a host function with a given native function and its signature. When we design the high-level API, we make use of the language features like trees and macros to simplify the API and also make it more readable for developers.
Sorry, Sam, that was just someone's mic. They've come and left, so please continue. Sorry about that.
Yeah, it's okay. It's okay.
Continue.
Thanks. Let's go ahead. WasmEdge Rust bindings is designed for Rust developers, obviously. So when we design SDK, we borrowed some design patterns, which are widely used in other Rust projects. For example, the builder pattern plus method chaining used in the top code sample in this slide can make the coding process more fluent, and the final code looks more elegant and easier to understand for people than the bottom one. So due to the limit of time, we don't talk too much more about SDK. If you have interest in this script and want to get more details about it, please visit our GitHub repo. Now, let's talk about the latest version of WasmEdge Seeds. Due to the changes in WasmEdge 0.10, we also introduced some new changes in the version 0.7. Today, we just want to talk about 5 major changes. The first one is we introduced a module instance object. With this object, we gain more flexibility in the API design. Besides, the state of a in-memory Wasm module can define much clearer. Second, the latest version of C script replaced the original import object concept with module instance to distinguish a module that is viewed as an instantiated module or as an import module in concept. We introduced as instance and import instance trees. The third change is WasmEdge 0.10 refactored part of the C API and also introduced some new ones to couple with the new version of the C API. We refactored part of the Rust APIs and also designed some new ones. To use a uniform error handling mechanisms in both Cs and SDK crates, we migrated the original error handling mechanism from Cs into types crate. The last one is about the API Rust doc. The major change is updated the Rust doc with the latest changes in API, as well as more code samples. In the next versions of SDK and syscrates, we plan to finish the following important work items. The first one is to support async operations. According to our recent investigation, we'd like to introduce a lightweight, single-threaded async runtime at the level of Rust bindings. And then, based on this runtime, to support some async I/O features. The second issue we'd like to solve is to improve the current error handling mechanism design used in our host function. The current design cannot handle users' custom error code, so we have to solve the issue. The last one is about WasmEdge book. So far, the Rust SDK section of WasmEdge book is based on cscrate. From now, we'll move the focus on SDK crate. That would also help the current users of sys APIs migrate to SDK APIs. Okay, thank you. If you, in the previous slides, we introduced the progress we made in the last 2 months. So due to the time limit, we cannot share to cover every corner. So if you have interest in some part, please visit our GitHub repo for more details. Thank you very much. Team.
Great, thanks, Sam. Excellent. Some good info in there. Thanks so much for that. I just wanted to direct everybody to the book that Sam just mentioned right at the end. Probably the easiest way to get it, if you just go to wasmedge.org, you'll see along the top, it's just got a header with a link. It says docs. If you click on that, it'll take you to the book. And the book's a really great place. If you haven't already used WasmEdge, it's a really great place to get started. Just obviously starts you with a quick one-line install and gets you off and running with some demos, and then goes into all the the more complex things that it can do. So yeah, the book's really well written, I think, and it's a really great place to start, and it's very easy to just go through and get stuck into it. So go check that out. All right, thank you, Sam. That's excellent. And next up we have Oscar Spencer. Now, Oscar's the co-author of GrainLang, and we've been chatting this past week and checking out a few things that are going on there, and I find it really interesting. We're going to have a quick chat to Oscar, and then there'll be some chances to ask some questions. I think with Grain, there's what I see is a focus on like high-level syntax, which is essentially aimed at onboarding developers to try out WASM, and I think it's capable of like removing barriers to entry and creating a more frictionless experience, which is of course great for WebAssembly as a whole. So I find it great that Grain is specifically a language like it's made exclusively for WebAssembly, so it's very purposeful, and I really love to hear what Oscar's got to say. And I guess the first thing is, Oscar, could you please talk about your vision for Grain? Share that with us. That'd be great.
Yeah, absolutely. And thanks so much for having me here today. Yeah, so essentially, what we're trying to build with Grain is a very high level, effortless language for WebAssembly. So we want to build a language that folks just feel extraordinarily comfortable. It's just so accessible for people to come into WebAssembly. I think for a lot of people right now, WebAssembly seems like this big, daunting, hairy thing of like, okay, I've heard about this technology. It seems really cool. There are all these runtimes and whatnot, but I don't actually know how to get started with WebAssembly. And like, there's, a bunch of guides out there and whatnot, but it would be really wonderful if it were just as easy as someone to write a program the same way you write a Python program. right? You write your first Python program, you download Python, you write print hello world, and you run Python on it, and you're done. And that's the same experience that we give people with Grain. You download the Grain binaries, you write a Grain program, it happens to also be print hello world, and then you can run the Grain CLI on it, and it'll both compile it to a WebAssembly module and execute it for you, and you'll see like, you know, that hello world message appear. And that's sort of exactly how we want people to feel about WebAssembly and getting into it. It's not, you know, this big scary thing. You don't need to go learn C code. You know, Rust is an amazing language. Like, I absolutely love Rust, but it's not for every single developer out there. I'm certainly, you know, there's tons of folks who maybe are more comfortable with something like JavaScript or Ruby. And if they had opportunities to, you know, get into WebAssembly in a little bit easier way, you know, they take it. So that's a lot of what we're trying to do with Grain, just building this very high level developer focused language where, you know, you can solve 80% of the problems that you need to in a language like Grain, where it's going to feel a little bit more like a scripting language. You can do your rapid prototyping, get something out the door. And maybe that last 20%, if you have some piece of code that needs to be really high performance or needs to be some special cryptography library or something like that, you can, you know, take on your Rust language.
Yeah, awesome. That makes a lot of sense. And I, you know, obviously went and tried it out, just land on the front page. I saw your talk at the last summit, and it was exactly that. You just go in, follow the prompts, and within like maybe 2 minutes or under 5 minutes for sure, you've got something running and it works. It makes sense. You can look at it. I like that with the Grain compiler. You can you know, put in a compile command and it will just compile, and then you can run it, or you can just you know, say Grain and the name of the file, and it will do both of those things. And what I found interesting was I went ahead and wrote a Grain program and then compiled that with Grain. And then once I had the WASM file, we're able to use the WasmEdge to actually take that WASM file and AOT, so ahead of time, optimize it, which then produces another WASM file. And then we're able to run that ahead of time compiled, optimized WebAssembly binary in WasmEdge runtime. So I think the thing for Grain is that it can run on multiple runtimes, right? And so I find that exciting. And the other thing, which is really great, is now we basically you've implemented linking modules into a single WASM file as opposed to separately compiling and linking dynamically at runtime. So now we're into the server-side world, which is
really absolutely
cool. Now that opens up a whole new ballgame. So I think that's really excellent. And I just heard before Hydai saying, you know, they're implementing in WasmEdge tail calls and things like that. I know that you're
so exciting.
Yeah, that's really cool. It's like orders of magnitude faster. And so that's a really exciting development there. I'd really like to try this out, you know, continue on with this, because we notice like between 30 and 200 times performance increase in the ahead of time compiling, like that optimization where we take the, even in Rust, like we'll compile something and then of course we can run that, but if we AOT optimize it, produce that second WASM file and we run that, it's way faster. And we've done things, you know, like image processing and things like that, where it becomes really useful, like any of the machine learning AI stuff. And I think the plugins that WasmEdge are doing now, where instead of using, you know, native binaries, we're actually packaging it up and putting it into the WasmEdge runtime system. So this is all very exciting, and it's reasonably early days. The next thing I was wondering if you could talk about like when to use Rust and when to use Grain. I've got a couple of specific questions, but maybe just an overview of that for us.
Yeah, absolutely. I think it's sort of the same way you think about, you know, writing a program in Python or Rust, right? Or sorry, not Rust, Python or Ruby, right? Where you want to build some application, you say, hey, I want to build this thing as fast as possible. Like right now, I'm not like, I don't care about performance. Not that I can't get really good performance out of my applications, you know, written in these higher level languages, but right now I'm not super, you know, caring about that. I just want to get something out the door really freaking fast. And that's when you should choose to use a language like Grain. So you say, hey, I'm going to build this thing. Like Grain's got its vast standard library. We've got all these tools to make things go fast for you. Like we got this amazing language server. Like you're actually in it, developing your programs, getting something out the door. It's going to work for you in 90% of cases. And like you said, with WasmEdge, you can actually take those modules, which maybe are, a bit slower than something you might write in Rust, but you can ahead of time compile it and those things fly, right? These modules are going extremely fast. You're going to get all the performance you need. You're going to build your stuff. It's going to be easy to refactor your code and you're happy. And then the same point at which you might say, hey, I have this application and I have this piece here that is really mission critical to the application. It makes a lot of sense to go and write that piece in like something like C or write that in Rust. It's sort of that exact same mentality of, hey, okay, now let me go and rewrite this one piece of that application. And what's kind of beautiful about this as well is, WebAssembly is continuously evolving, and we have this concept of the component model of WebAssembly, where we're actually going to be able to stitch different pieces of WebAssembly together, compiled with completely different tool chains. And so right now, this is still possible. There are systems that you can make right now where you have pieces written in different languages. But of course, in the future, you're going to be able to actually call into other modules, across module boundaries, and it's going to be a really freaking good time. But yeah, Grain definitely aims to be that first 80% of code that you want to write, of just, let me bang this out, get this out the door, put together this library. All of that.
Awesome. Yeah, that's right. It's just it's an array of like microservices now. You can just start having lots of small defined functions that can perform specific tasks and lay that all out, which is a great way to develop, right? Because you're not bundling it all up into one big heavy thing. You're able to like separate everything out and
exactly.
Reuse, all those dry principles and all that stuff. So yeah, that's really cool. Now, the other thing I was just curious about, we're taking like the best bits, right? So I see you take the type checker from OCaml and you've got like the let mute from Rust. So this is, this speaks very much to the goal of you're trying to create something that's optimal, and you're literally taking the best bits, whether it's a new language or it doesn't matter if it's an old language. If it's good, you'll take it.
Exactly.
Is there, you're continuing to do that? You're just finding what works, what's smart, and you're just implementing that on purpose, right? So it's
absolutely on purpose. The whole idea is providing this amazing developer experience to people. And so my best developer experience ever has been using languages like OCaml, where they have these really strong type checkers. Now the question, of course, is, where does this fall short? Because for a lot of people, why isn't OCaml the most popular language if it has, this amazing, developer experience? And I think there's a couple of things that keep people from using more functional languages, right? But we've started to see languages and frameworks. So if you look at something like the React front-end framework, right? Like this is, it's JavaScript, but it's taking in all these functional concepts, and people really dig that. You look at something like Rust, where like, it's like this sort of C-like language, but bam, we've got pattern matching. We've got, really solid, like borrow checking on, not just memory stuff, but also like all of our types, and we know that we can feel safe and really comfortable, right? So that's the place that we want to start. That's where we want to come from, is, hey, let's start by just giving that amazing experience of, hey, I can write code and I can be confident that that code is more or less correct when I write it. The types line up. If I want to refactor this code, it's not a huge deal. One of the things people love about Grain, and languages like Grain, is that you don't have to write type annotations on anything. You can just write some code, but the type checker still has your back the entire way. And we've also got the language server, so when you're in VS Code or your editor and you're writing code, it's still telling you, hey, these are the types of all these things, and it's going to be this type. You're not worried about something switching out from under you, right? So you've got all that sort of safety, right? And then, like you said, just pulling in features people love, like let mute, right? That's something that you probably would never see in a purely functional language, but we pulled it in anyway. And why? Because sometimes some people just want to write a for loop. Some people don't want to write that purely functional recursive function, that I might feel really comfortable doing, but that's not everyone. Sometimes you do just want to like write just a simple like loop to get something done, to just update some variables in like a more comfortable style. And that's sort of what Grain is really aimed at, is that rapid prototyping, but also making sure that this code is readable, understandable, and refactorable. So it's nice that we've got all these different pieces coming together.
Yeah, awesome. I think one thing I like about it too is the simplicity of the syntax. I guess we call it like syntax sugar or syntactic sugar or whatever. The one that I loved is like the product. like list. So I pulled in like a WebAssembly file with a whole list of numbers, and you, by just typing like list.product, it's essentially like a cross join. It's going to find every permutation of every one. And I think you even did it like a triple. So it'll go through and find, you know, cross join everything and produce this gigantic big additional list. But it's literally one line of code, and it makes sense. You just list.product, boom. It's that simple.
Right.
So
exactly,
I really like that. It's very cool.
And that's exactly, you know, our philosophy of like having that really strong standard library where it's like, you know, for a case like that, like, yeah, you can write a faster algorithm for a lot of places, and you can do it in Grain as well. It's not that Grain doesn't support it. But the idea is, you know, let's get the application written, let's get it out the door, let's get it running. And then if something's not performant enough, we can refactor it. And the Grain compiler makes it really easy to refactor things after the fact. Right. So like, that's the exact idea that we're going for, is like, yeah, I'll get that one liner in. I'm not worried about this. Like, I've got my generics. I'm happy. I can reuse all my code all over the place. You know, and it's a good time. And just beyond that, just supporting features developers love, like, you know, pattern matching, exhaustiveness checking, making sure you're not missing edge cases, you know, things like that. So yeah, just pulling in those best bits of Rust and OCaml, and even there's bits from JavaScript that we take, and some people say, oh no, don't take anything from JavaScript, but you know, there are bits that people like, and you know, just pulling all these things together into this one cohesive experience.
Yeah, one thing I really like is print.
Yes.
It might sound funny, but you just type print open parentheses and it will print anything you tell it to. And in
anything
most
at
languages, it won't, right? It's like most languages, oh, I can't print that. And as much as I love Rust, you always have to, it's a bit of a Barney with the compiler to get it to, but you just, I tested it out. No matter what you create, you just type the word print parentheses, put something in it, and it'll just print it. It's great for debugging, right? Which is what WebAssembly really needs. So
yeah, this was incredibly intentional, because that is a problem right now in WebAssembly. Yes, we will get better debugging tools. Like, we'll get Dwarf everywhere. We'll be super great. We'll have source maps and everything, but we're just not quite there today. The tooling isn't quite there to make it that useful. But give a developer a powerful print statement and they can do anything, right?
They'll figure it out.
They'll figure it out. You know, there's no worrying about like, hey, I need to get some, you know, like derived macro, or I need something like this that I need to remember. Like, oh, this is how I can make this thing printable or whatnot. It's just, no, I have this data, I want to print it, I want to see it, and then I'll go transform it and do whatever, right? And then of course the next question is like, well, can we do that and still have it be fast? And like, can we still get small, you know, binaries? And yeah, we can. We've got a flag that's -- allied type info. And so when you're, you know, compiling your modules for production, you use like -- release -- allied type info. You can get those small, you know, modules, and yeah, your print's not going to do all the amazing debugging prints that it did in development mode, but you know, you've got enough to, you know, have your programs running and still get those nice small, you know, compact, you know, modules. And yeah, it's a lot of, it's exactly just a lot of what we're thinking about. What is your experience as a developer, knocking this code out and moving on to the next thing? And yeah, that's
great. Then I had a little question for you, because the one thing I do love about Rust is, like you say, the compiler's got your back. I love that about Rust. It almost tells you exactly. It's quite amazing. It'll even suggest, you know, the replacement code. Hey, have you considered trying this? And you put that in and it works. So to me, that's amazing. The compiler is your friend and it's totally got your back. I was looking at the recursive keyword, so rec, and I just wonder if you could talk a little bit about that, because obviously in something like C, like taking the Grain example, in C, the logic for, say, like Fibonacci sequence, which you've got an example of, is basically the same, you know, aside from the rec keyword and the explicit return statement that Grain has, like similar to Rust. What does the rec keyword actually do? Is that just so that the compiler can like stop a developer from accidentally calling their function recursively? Is that what that does?
Yeah, that's exactly what that is. And it's funny because this is a question that I actually get quite a lot, because a lot of people think, oh, you know, well, a lot of languages I use, like, yeah, stuff is just recursive. And I think this really comes from functional programming, where by default, you know, our bindings are not mutable, which means that if you want to reuse a binding in a safe functional way, you just recreate it. So you might say let foo equal this string, and then if you want to do some transformation on that string, you'll just say let foo equal transformation on foo. You know, that's something that's very common, is to do this sort of type of shadowing, which some people are maybe a little bit wary of it because they've just been burned by shadowing, in the past. But especially like having a language with a really strong type checker like Grain, having the support of your editor that's telling you the types all along the way, it's a very different experience, right? And so to support this, if every binding were recursive, that would be a nightmare.
Yeah.
You wouldn't be able to shadow like the same name, back to back the way that we often do in functional languages. So the rec keyword also very nicely, when you start reading that function definition, something's up. You see let rec Fibonacci, and you immediately know, hey, let me buckle in because this developer has decided to use recursion in this function, right?
Yeah.
And so it's a really nice signal, just visually, and then you see that keyword there. And plus, the compiler will let you know, like if you write a function, like if you did just let Fibonacci and tried to call it recursively, the compiler is going to tell you, hey, this function's not recursive. Did you mean to make it recursive? And you're saying, yeah, definitely. That's exactly what I wanted to do. You tell the compiler, you tell the people reading the code, and everyone's having a good time.
Yeah, awesome. Yeah, fantastic. Have you got any questions for the community or for us? I know we've done a couple of things this week. It's been really interesting, and I really want to do more. I'm excited about that. And to the community as well, to the participants on this call, this is a really great opportunity to ask some questions, and there's no wrong questions, right? We just
no wrong questions whatsoever. Obviously, Grain. Obviously Grain's still early days. We're still building out the ecosystem. I mean, we've got quite a pretty robust standard library at this point, but obviously still building more and more, trying to support more and more WebAssembly proposals. We're absolutely thrilled to hear that WasmEdge, the latest version, has tail call support. Like, that's huge, because obviously we're writing lots and lots of recursive functions where the tail call support is really, really helpful. So yeah, we're still building. A lot of it is based on user feedback of folks writing programs and saying, oh yeah, I really wish I had this, or it'd be amazing if I had this. And we're incorporating all of that feedback, as we're building. Yeah,
fantastic. So anybody in the chat, has anybody got any questions for Oscar or for Sam or for Hydai? Hey, Michael.
Hi, team. Yeah, so I just want to make a comment about, so Oscar, that's, I think we met in person, but
yes.
Yeah, so, that's, I'm back in the States, so hopefully we can meet in person again soon.
Yeah,
so,
absolutely.
Yeah, so one of the very interesting thing about WasmEdge, at least from our point of view, is that it's easy to add plugins. Like Hydai has said, there's, so we already have a lot of, I would say, convenience features. So, for instance, networking, AI inference, image processing, and all that stuff. And we are with the new plugin framework, we are adding a lot more. Meaning HTTPS networking. That's one of the top demanded feature, because when you interact with other systems, right? So we have different ways to do that through Wasa Crypto and also through host functions, like plugins, So but it's only one side of the equation. You add those features into the VM, but however, on the other end, you have to expose those features to the developer too. The developer, when they write applications, they need to be compiled into API format that can, the bytecode format that can invoke those functions, right? So far we have done a lot of work with Rust and JavaScript to a lesser extent, because that's so whenever we add features like this, we always have corresponding Rust SDKs, that will allow people to write those applications. And because the close association between Rust and our implementation of JavaScript, the QuickJS, we have a Rust API to extend QuickJS. So it's also fairly straightforward to translate those Rust APIs into JavaScript APIs, that can run on WasmEdge. So I would love to do that for Grain as well, so that we can have Grain as a first-class supported language. Because when people are talking about language support in Wasm, technically they can all be compiled into WebAssembly, right? But
yeah, this is an argument I use all the time.
right. So yeah, that's this is one of the things, as soon as you start developing for this platform, you'd find this is a shortcoming. There's only so many languages that you can use, and a lot of those languages, you are a bigger expert on this than we are, is that they are not really designed for WASM. So, the compiler generates a ton of JavaScript code that has to go with the library, right? That basically ties you towards, that's running in V8, things of that nature. So we are trying to, break free from that and to make it more like a standalone environment, like the JVM used to be. I think, that's I would really, hope that Grain would be a language of, that's that would make it easier to adopt, and so we want to support that. So what's the best way? So it's a long-winded comment, but I do have a question. So so what is the best way to adding new SDKs and features into Grain? Is that using Grain to implement Grain, or using Rust to implement Grain? Something that's. Sorry if that sounds ignorant, but that's that's my question.
No worries at all. Yeah, no, I'd say it's definitely going to be within Grain. We have a syntax to bind host functions. Because Grain is a higher level language, and usually these host functions are just a very low level interface. It is sort of a bit of a disconnect. Now, I know you all have the WasmEdge binding project for Rust.
Yes.
I'm curious to hear, how compatible is it with WebAssembly interface types?
Hydai, would you be able to comment on that?
Well, the current binding is not using the interface type proposal, but as far as I know, which is that the binding is trying to adapt to the interface type once this proposal is ready. So I believe it will be the the next standard, and one day we will always follow this standard to update our binding.
Awesome.
Is it preferable for it not to support interface types in terms of like complexity to implement it?
So it's because of the interface types proposal. Sort of, I've had a fork of the there's a project called WitBindgen, which can generate bindings between interfaces and whatever language. And I've had a prototype of this for Grain for a long time that's been on the back burner. If any of you follow Grain, you'll see that we just put out a huge release this past weekend. So all of my energy has been focused on that. But now that that's done, I can actually get back to the binding generation. But if the WasmEdge host functions are all fairly compatible with interface types, I can actually probably bang out libraries really quick, and we can probably get people playing with this stuff this week, which would be pretty cool.
Yeah. So I may clarify this a little. So the WasmEdge binding is actually on the other end. Is to have the when you write a function that compiled into Wasm, you need to call it from other languages, right?
Gotcha.
My understanding is that the host function is other end, is to Wasm to the native system. So on that end, we do support. I think. That's because the interface types isn't finalized yet, but there are. That's we are. I think we should compare notes to see how compatible that we are. That's given given the current standard. But I think the other way is also important, because as we know, that's the thing I keep telling people. That's why you don't see Hello World in Wasm, is because it doesn't handle strings, right? So all the examples that people gave are numerical examples. That's like you have just said, computer sequence, something of that nature. You can never say hello Spencer, right? That's so that's in order to do that, in order to make a function that takes a string and call it from outside, you need another binding, which that's in the I wouldn't say in the old days, but in the browser days, it's a Wasm binding. That's it has tight JavaScript couplings, right? So WasmEdge binding really try to avoid that, so that it can be used in the WASI environment, because the Wasm binding itself doesn't even compile if you have the WASI target count turned on. So so that was actually a way to get around that. So I'm also curious. What's the solution for that in Grain? So you have a function that's written in Grain. how do I call it from outside? Say function takes string as parameter. Yeah.
Yeah, so that WitBindgen project I was talking about does both sides.
Okay.
It'll generate code on the Grain side to make a WebAssembly interface types compatible layer. And then on the other side, it can do a number of languages. So it can bind to Rust, it can bind to, I don't know if there's a Go one just yet, but it can bind to C, it can bind to JavaScript. So it can bind to quite a few of these languages. So it might actually, even if we wanted to just incorporate some of the output of it into WasmEdge bindgen to just have those binding, which actually it sounds to me like it's already probably just going to work from the WasmEdge side, and it's just a matter of if we can bind to the host functions, everything should be working. So I'll just play around with it today and see if I can get it working.
Yeah. That's I think that's let's try and find a way to make it work. Because that's probably the I wouldn't say the single most important thing, but that's a roadblock. That's has to be resolved before and after that we can do a lot more. Yeah. So.
Yeah, absolutely. And then it'll just be pretty easy to just have those SDKs available and people can just use them. Yeah, absolutely.
All right.
Very exciting.
Yeah, really appreciate that. Yeah.
Yeah.
I've got a question in the chat here. Richard is asking if Grain has monad support, and I'm hazarding a guess we're talking about like function composition technique. We're like talking Haskell. So is there monad support?
Yeah, so that's a great question. So it depends on exactly what you mean. Is it possible to create a monad and use it? Yes, like we have enum types. So you can create a data type that is generic and can wrap something. You can create a bind operator and put these things together. So you have all the pieces to make monads and use them if you really wanted to. But I think what most people really want when they say monads, especially like sort of how we end up using them in OCaml, is composition of module functions themselves and having modules that can compose around each other. And Grain doesn't have that just yet. That is something that's on the roadmap that we will be working on fairly soon. But if you want to have just sort of monads in the literal sense, yeah, you can create a type and you can bind them and do all sorts of fun things with them if you really want to, from more of a theoretical sense than a practical sense.
Okay, great, thanks. Anybody else got some questions or comments? Don't be shy, just fire away. Richard says, awesome, thanks. So you've answered
Absolutely.
the question. Yeah. Anybody else there? So question here in the chat, any particular vision for the backend of Grain Lang, like certain kinds of optimizations for WASM which allow all types of data types?
So I'm not sure I quite understand the second half of your question there, but in terms of the first half with optimizations, Grain uses Binarian as our WebAssembly backend. So we have a number of Grain optimizations that run on programs when you compile them. So sort of a lot of things kind of to enable Binarian optimization. So if you're not familiar with those, if you've ever heard of WasmOpt, that's what that is. So essentially, we run all the Grain optimizations, and if you compile with the -- release flag, it'll run all of the WasmOpt optimizations as well. But if you clarify what you meant by the different data types, I can probably answer that as well.
Yeah, I haven't specified, but maybe they'll comment in the chat. Hopefully we've answered that to a degree.
Something like bindgen. Yes, we really want to have bindgen be a nice experience in Grain. We don't want folks to have to go run a tool. We just probably will have like an attribute or an annotation that you put on a function and just say, hey, I want to bind to this function, and it will automatically generate those bindings within Grain for you. That's definitely something we want to do, and it's huge because I think it's going to be the thing that helps just get Grain more attention from a lot of people when it's really easy to bind to all these hosts that they want to bind to, right? It'd be amazing if, like, for example, just with WasmEdge, if you could just annotate a function and say, hey, I want to bind to this thing, and then that's it. That would be really lovely, instead of having to have an SDK, for example. But we we'll get there. It's still going to take a little bit of time, but yeah, we absolutely want to have amazing binding support in Grain. And it's actually, and even to add on to that, it's actually going to be something that'll be really nice because it's not like we don't know the types. We have a very strong type checker. We know exactly what the types are, how they should be represented at the WebAssembly level, how they should be represented as WebAssembly interface types. It's not terribly difficult for us to do that sort of translation. So yeah, absolutely.
Cool, awesome. Yeah, I think that's a clean way to code too. I saw that with the tail call, like you just have that at the top of the file, so it's clear. And I know you've got some flags in the compiler, but I think that's more for like optimization and things like that. I remember when a while back, a couple of years ago, looking at compiling and looking at the size of the WASM binary and just adding like a print statement in the traditional sense. It was a much larger output if you just had that one request to print something. Like it was extraordinary. I forget it was like, I'll make this up, but it was something like 20,000 lines versus 7. It was ridiculous. And I was thinking, so now what you're doing is you're essentially having flags that you can turn things on and off and choose. And so I think it's really great. The way it's been built is it's really deliberate and purposeful and great. So it's excellent. Yeah, good job.
Yeah, and we're just getting started there. There's so much more we want to do around developer experience. Like we want to put together, a full build tool to actually manage compiling all of your Grain programs and compiling for different WebAssembly targets and things like that. So there's so much more we hope to do, which of course we can do with your help. I mean, if you're interested at all in build tooling, or if you're really trying to get your hands dirty and do work actually working on a compiler, we're more than happy to have you come contribute to Grain. We're always looking for more open source folks.
Yeah, awesome. Really great. Okay, so looks like we've answered that. We've got a great thanks. Look, that's really fantastic. Thank you so much for joining us, Oscar. It's been an absolute pleasure, and let's collaborate. Yeah, it's fantastic. And I hope everyone's enjoyed today, this morning, wherever you are. If anybody's got any more questions, we'll do those right now. Otherwise, I guess we'll wrap it up. We're just a little bit over 1 hour, which is perfect. So any more questions, please jump in.
Yeah, and thanks again for having me at your meetup. It's great to be here, and it's amazing to see all the work you all have been doing.
Yeah, it's a lot's been done in a couple of years, hasn't it? In this space.
Absolutely.
Yeah. Guys. Yeah. It's amazing. Yeah. All right. Well, I think that's about it. I think people have enjoyed that. There's been a few questions in the chats, and yeah, thanks, Brad. Thanks to everyone, especially thanks to Oscar. Thank you, Brad. Thanks for joining us. And I guess that's a wrap. We'll see you guys next month.